confused about signing and marking at multi-lane roundabouts? So you submit the abstracts to try to get selected for presentation, and then you got to put your presentation together, right? So what are the learning objectives? What do I really want everyone to come away with after my 50 slides? I want you to understand some of the challenges and issues faced with signing and marking with multi-lane roundabouts. Be able to apply some of the lessons we've learned and look to achieve optimal results, as Jeannie so well put. So the outline today is separated into 4 components. First, an introduction. We're going to look at some examples. And then section B is we're going to look at some of the MUTCD and some of the differences and best practices and the different schools of thought there. We're going to look at 2 case studies briefly, lessons learned from those. And then finally, a few slides on an optimization example where we looked at using a model, 3D model, so we can look at things in a driver's perspective. So signing and marking is one component of roundabout design. There's geometrics, there's signing and pavement marking. Multi-lane roundabouts have more traffic, there's more lanes, and therefore more conflict points, and therefore things are more sensitive. Drivers' behavior is more sensitive to the design. And pavement markings and signings are integral to the design. But for today's purposes, we're just focused on marking and signing. So first, you know, we've sat through problem multi-lane roundabouts. Those get a lot of news, and I thought, you know, I'm going to throw in a few slides of some multi-lane roundabouts that are doing well, okay? So here's a project that I was involved with in design. We opened in 2006 in Wisconsin. It was the first 3-lane roundabout in Wisconsin. And that project has 5 years of crash data that the most recent that I looked at. It's carrying about 45,000 ADT and it's averaging about 15 crashes, PDOs per year. So this project has 9 conflict points. As we try to quantify some of the differences between projects, and you know, you're entering lanes times your circulating lanes opposing that entry, and you add those up and you have 9 conflicts. So okay, that's pretty good. Here's a project that I worked on. We've been tracking those crashes over the year after year. It's been open now for about 5 years approximately. And it's averaging about 20 a year. It's a 2x2 roundabout. It's carrying approximately 30,000 ADT. And this is a 2x2 roundabout. So 2 times 2 times 4 is 16. That has 16 conflict points. So part of the issue is, well, how many is the right number? We don't really know. You know, the practice is evolving, and we're really just starting to get data out of some of our projects. And then lastly, one that I was involved with recently in California, very sensitive at the entrance to Pebble Beach Golf Course in the Monterey Peninsula. And this one has 8 conflict points, and it's having about 5 PDOs per year. So that's doing really well. It's about 25,000 ADT. So there's a lot of things that come into play. This was voted the best use of government funds in 2017 by the local paper. So back to the topic at hand, really. Human factors research. The research says negotiating intersections involves the absorption and processing of visual information presented to the driver primarily by the signs and pavement markings. And this is general. This is not specific to roundabouts. This is predominantly focused on traffic signals and other roadway components. So if that's true for everything else, it's true in spades for roundabouts. They say design should reduce demand made on drivers to improve comprehension. And they say the design should adhere to drivers' expectations and experiences. And lastly, then, our design objective is to minimize the detection, reading, and processing time. This is based on the User's Guide to Positive Guidance. I think it's an ITE document is where I got this from. It may be sourced from somewhere else. And then maximize comprehension. What do we think? Did we hit the mark? So then the researchers call this very compressed information. It has a high cognitive workload demand, and there's information overload. I like the snippets, as we all do. A driver says, it's a little frustrating because there's a lot of signs to read in a short period of time. We can all agree with that. So it's easy with multi-laners there's a high risk of information overload with multi-lane roundabouts. We tend to end up with a lot of information out there. Just a couple of quick examples. showing what that looks like from a driver's perspective view on a project. So here's another example of an advanced directional signage. All the information's there. It's a large green sign. It has a circular symbol in the middle. But can you really tell what means what? Not really. So here's a good example. The researchers say that we should place signs according to their importance of their information and look to organize information into larger units of color and shape. So the UK, that has decades of experience with roundabouts, this is what they do for their advanced directional signage. They have different widths, they have different colors, you can identify major roads and minor roads. It's going to be a lot easier to comprehend. Here's a US example, a project of mine, where I use this as an example of lots of information, overhead. This area, this region, has sort of a cookbook approach for signing. If it's multi-lanes, they put all the information on the sign. You end up with very large overhead signing, which I think are incongruent for the slow speed approach and a slower speed roundabout. They look like freeway signs and interchange type signage, which is a high speed facility. Gene Hawkins, who was the chair of the MUTCD committee in the development of the current 09 MUTCD, says cookbook approaches are not advised and that it should be a principles basis. Similarly, on our exit signs, the tilt arrow was borrowed from off-ramps. Off-ramps and roundabout exits are very different. They're not the same. But sometimes the signing engineers perceive them perhaps similarly. Off-ramps are high speed, very different geometrics. Roundabouts are low speed with different geometrics. Researchers have found that chevron ends minimize detection and improve the recognition of the leg of choice. All right, section B, MUTCD. There's the joke for the presentation. So we're going to look at three components: the lane use assignment, and the circulatory roadway markings, and the yield and entry markings. So briefly first, from 03, which the one before 03 was 1998 MUTCD, went to 03, and then it took 7 years for the roundabout section and the 09 MUTCD to come out. Barry Crown, one of my mentors, design mentors, participated in that. They incorporated a lot of advice that he had given to that committee. But Gene Hawkins, who was the chair of that committee, in hindsight, says many on the it's a consensus-based approach, so they vote on certain things. And many had very little or no practical roundabout experience. So number one, lane use assignment. So there's different schools of thought. You can see my little icon there in the corner. There's the fishhook. So someone wrote a white paper many years ago, and we were concerned about wrong way lefts. And the diagrammatical or fishhook signage and markings was born. It's not based on any research or science per se. It just seemed to make sense. And in plan view, it does seem to make some sense. And a lot of people liked it. I always joke that I always thought it sends the right chemical drip to the engineer's brain that makes you feel good. When I was doing roundabouts at WSDOT and had the ability to influence their guidance, I didn't want to put new things on top of new things. So I always was in the camp or the school of thought of where I can, I want to use conventions that drivers are already used to, as opposed to the other school of thought, which is, well, roundabouts are different, we should put something different. Two different schools of thought. So from a driver expectancy, from what drivers are used to on the roadway, this is what you typically see at all our other signalized intersections, standard lane use assignment. So that was the reason why I liked the standard signage. Another reason that I liked the standard markings and lane use assignment was with the fishhooks, we put them on the approach, but then the circulating has standard. And I thought that was incongruent and inconsistent for driver expectancy. So here's a look at, the straight ahead arrow is the one that is the most pronounced with the fishhook style. The curvy arrow to me seems odd from a driver's perspective view. So here's an example of a project that just looks at the standard on the approach, standard circulating, and standard overhead on this project. You notice the the East 19, South 119, I think that should go away as well and really clean it up. Item number 2, circulatory roadway markings, solid versus skip versus a consistent line type. So this is what's shown in the MUTCD and all their diagrams. So many projects naturally use that on their designs. Our program at Wisconsin was pre the 2009 MUTCD, and so a lot of projects were having people circulating on the outside lane and then crossing in front of someone who's exiting. And so as we look at all of our other roadways, when we have solids and then a skip style marking, which is what's shown here on the bottom, it's a weave opportunity. So we shouldn't be too surprised that we've conditioned drivers that when you see a skip, you can change lanes. And I've argued that you don't want people changing lanes or having any idea that it's okay to change lanes without looking really closely first at the roundabout. So this has been termed a strong line. I refer to it as a consistent line, which is consistent with international practice for markings to use a consistent line. It adheres to driver expectancy. Here's an example showing what that looks like. This has a spiral marking, and the line is the same all the way back to the spiral point. And then I use inside lane a little narrower, like 10 to 12 feet, and the outside lane becomes wider. I'm not going to get into the details of that, but that helps other aspects of design. Lastly, the markings and the yield line. So the edge line extension description in the MUTCD comes from highway and roadway engineering, edge line extended. Again, roundabouts aren't roadways necessarily. It's an intersection. We don't call a stop bar an edge line extended. It's a stop bar for the approach traffic. It's not for circulating traffic. The misnomer is that drivers circulating are queuing off the right side or that edge line extended for guidance, which they're not. You'll notice if you observe drivers or observe yourself, you're circulating counterclockwise, so I don't know if that's, and you're queued off the left side, either the markings or the curb. You're not looking to the right. So you don't need that edge line extension for guidance for circulating. What we need is markings for the approach drivers to try to understand yielding. And so a singular bold priority line is something that I've gravitated towards as a means of trying to provide more concise and clear information as to of what we want drivers to do, which is slow down, be prepared to stop if necessary, and or yield. I've even gone so far, and I'm a little surprised, that I'm wondering about the yield markings themselves. Do we even need those? Just a heavy demarcation line, perhaps. Here's another example just showing that heavy yield demarcation line. So part C, 2 case studies. So just using signing and marking, and this first project is only markings. So they were having a pretty clear pattern of lane discipline type crashes at this project, and this is what it looked like at the entry as a driver. There's lots of different line types that it's hard to differentiate what means what. So we wanted to fix that. And so we removed some of the markings, we placed a singular heavy yield line, if you will, as well as we changed the circulatory markings to have a narrower inside lane. In this case, we went down to 10 feet, and whatever was left was about 16, 17, maybe a little more than that on the outside lane. That helped provide better alignment at the entry, improved our entry angles and view angles as well. So Joey Riddle, who's the safety engineer for South Carolina DOT, in preparation for this presentation, that was about 5 years ago we did that project. I said, how's it going? So over 5 years, initially the crash rate was quite high, but over the 5 years average, it's about a 50% reduction in their PDOs and their fender benders. He says, I'm sure the pavement markings need refreshing, and that's true. Pavement markings need to be refreshed, they need to be clear. We have to maintain our roundabouts, we need good pavements, mill and overlays, et cetera. But he says it's strong evidence of the importance of good pavement markings. Thanks for your assistance. So case study number 2, City of Richfield. Again, this is about 2011, I think. Project that I worked on up in Minnesota, a 2x2 roundabout had issues. I was asked to look at it and help them figure out if we could improve drivers' comprehension. And so we went in, and it had a lot of different issues. And it was all, contributing to lower driver comprehension. We removed the solid and skips. We set up a plan where we improved the channelization on the approach. We added more lane use assignment on the approach. They chose to use side-mounted lane use as opposed to overhead. It could go either way, but there's often contextual issues that can affect that. We used the consistent circulatory markings. And that had the circulating issue went away. We still had the entry, the yield issue was still there. Another thing that the yield signs, they're very close to the pedestrian signs, and they can often be blocked. And so in Minnesota, this was I think it was the first one where I was doing some research on the R16 sign, and we implemented the R16, and this project was heavily researched subsequent to the changes by John Hordos and his researchers out of the University of Minnesota. And that R16 sign, they really liked it up there. John recently gave me some data that showed a 30% increase in vehicular yield rates to PEDs pre to post our changes, which is pretty substantial. And that's consistent with the initial research on the R16. It's only meant for slow speed areas to provide more target value for those crossings. Design example. A design process example. Here's a project that multiple agencies, jurisdictions, DOT, county, and local interested. This is an entrance to Pebble Beach Golf Course. It's an interchange ramp. It's one of the primary ways into the peninsula of Monterey. So a lot of tourism and directional information. So we went through a decision-making process where we identified decision-making points. We built a 3D model using Google SketchUp, a relatively inexpensive way to put that together. And we looked at each decision-making point, what the different alternatives look like. There's a large green overhead. There's side-mounted. There's, we have standard overhead and fishhook style overhead. We looked at different alternatives at each point that possibly could do. There's the exit signing, 2 different exit signing approaches. And at the end of the day, it was a really good process in that, looking at things in perspective view really helped people understand and make good decisions. So in summary, multi-laners have more traffic, there's more lanes, there's more conflict points. The geometrics, markings, and sign, all are integral to the design. The criteria and best practices are still evolving. You have geometrics, sign, and pavement marking. There's greater sensitivity to imperfections. So like the 3 bears, you don't want it too hot, you don't want it too cold. Small design incongruencies can have an unexpected and disproportionate effect on driver behavior. It's hard to believe that little sign might affect people that way. So we want to simplify the decision-making, make it intuitive, easy to understand, adhere to drivers' expectations, and get it just right, just like Baby Bear. If you have questions, feel free to contact me. Thank you very much.